This is Unit 5, Video 16, Limiting Reactant. So in chemistry, it's really important to figure out in a reaction what reactant is going to run out first and what are we going to have excess of. We can't just take things, throw them together and say, oh, the reaction will continue on forever. Okay, we're going to run out of something. So if you think of a candle, you light a candle, you've got a certain amount of wax in that candle. Okay, we know that when you light that, the wax is a combustion reaction with the oxygen in the air. Well, we've kind of got endless amounts of oxygen in the air. So we would consider that. We're not worried about that one running out. But eventually, we're going to run out of wax in the candle. When we run out of wax in the candle, we're not burning anymore, so the reaction stopped. Now you can reverse that, and we could put maybe a cup over top of the candle, and the flame's going to go out because we've limited the amount of oxygen that we have combusting with the wax. So if we run out of something, the reaction's going to stop. If we run out of something, whatever we ran out of or whatever got completely consumed, we're going to consider the limiting reactant. Whatever is still left over, it means we didn't consume it all, we're going to consider that the excess reactant. Okay, and before you've seen, when we've done stoichiometry problems, we've said in excess. That just means we're not worried about that reactant, we've got plenty of it. The one we're doing the reaction, or what we're calculating, is only the limiting reactant. Okay, so what we're going to do now is we're going to look at a problem to where we need to determine what is the limiting reactant. So we've got to do a couple comparisons. Okay, so here we've got a combustion reaction with ethylene. We're taking ethylene, reacting it with oxygen, we're forming carbon dioxide and water, and it is balanced. Remember, stoichiometry, we've got to always have balanced chemical reactions. Okay, so here we're going to take 4.95 grams of ethylene. Okay, so this is our first reactant. Okay, we're going to combust it with 3.25 grams of oxygen. This is our second reactant. Okay, so what we're going to do is we're going to determine the theoretical yield of carbon dioxide. Carbon dioxide is our product. So what we're going to do is we're going to take this reactant and we're going to determine how much CO2 we're going to make. And we're going to do the exact same thing for oxygen and determine the amount of CO2 we're going to make for oxygen. Okay, whichever one's going to be the smaller amount is going to be the limiting, the larger one will be in excess. So the smaller amount's going to show us which one is going to run out first. So let's walk through a little bit of stoichiometry. So let's take 4.95 grams, and also it's really key when we do limiting reactants that you pick one product to go to. Normally in the reaction, in the problem, it'll tell you which product to go to, but sometimes it's not going to, so just pick one one product to go to. So here we're going to go to carbon dioxide. We're going to take 4.95 grams of ethylene, and we got to get to grams of CO2. So my first step is we need to get this into moles. It's going to be 28.06. We get that from the periodic table. We're in moles of C2H4, which lets us switch into the compound we want. So we now go to moles using the mole ratio. So C2H4, it's going to go on the bottom, and we're going to have carbon dioxide on the top. Okay, we go to our balanced chemical reaction. That is going to be a 2-to-1 ratio. Okay, now we're in moles of CO2, which we don't want moles of CO2 because we're doing the theoretical yield. So we need to know max amount of product. So moles going to go on the bottom. And we're going to go to grams of CO2. Get our grams from the periodic table. Okay, all of this should cancel out, leaving us with what we want, which is gram of CO2. So if you were to go through and punch all of that into the calculator, you would get the theoretical yield for 4.95 grams of C2H4 will produce 15.5 grams of CO2 only if we completely consume 4.95 grams of ethylene. Okay, so now we're going to do the exact same thing, but we're going to switch our reactants. Now we're going to do it for oxygen. So we're going to take 3.25 grams of oxygen. We're going to go through the exact same steps. We're going to convert it to grams of carbon dioxide. So gram of oxygen needs to go on the bottom, and we're in 1 mole of oxygen. Now we can do our mole ratio, which we get from the balanced chemical equation. So that's going to be a 3-to-2 relationship. Okay, now we're in moles of CO2, so now we can do the last step, which is converting it to grams of carbon dioxide. Okay, everything should cancel out. Mole of CO2, mole of CO2, mole of O2, mole of O2, gram of O2, gram of O2, leaving us with the unit we want, which is gram of carbon dioxide. If we go through and punch all this into our calculator, we will get that we will produce 2.98 grams of carbon dioxide. Okay, so what this is telling us is that 3.25 grams of oxygen will produce 2.98 grams of CO2. Okay, now what we're going to do, after we have two theoretical yields, we're going to go through and compare these. Okay, this is the smaller one. So what this is telling us is that the oxygen will be consumed first. Once the oxygen is consumed, the reactant stops. So the maximum amount of product we've consumed, or the maximum amount of product we can make, is 2.98 grams of carbon dioxide. This does not matter because we cannot produce this because we run out of oxygen. So we would call ethylene our excess reactant because we got plenty of it, we didn't use it, or didn't use all of it, and we would call oxygen our limiting reactant.